Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 12th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website, which I actually have pulled up for you here. You'll go down to grade 8, math grade 8. If you click on the student packet, that will have all of the student work that you can do with us today. Today we're going to continue our learning about systems of linear equations, and we will be working on estimating solutions by graphing. Before we get started, to participate fully in our lesson today, you'll need the following: paper and a pencil and a surface to write on. A calculator is not required, but may be used to check your calculations. Optional but helpful materials would be a straight edge and graph paper. Okay, let's begin. We are in week 3 of our 8th grade mathematics learning series, and we are working with equations and expressions this week. Let's warm up with a little mathematical practice. In lesson 11, we looked at this chart about maximum heart rates based on a person's age. Remember that X represents the age of a person and Y represents the maximum heart rate. Here's what we wrote in lesson 11. Y equals 220 minus X. Now, let's extend this to write and simplify an expression that gives the heart rate that is 75% of the maximum heart rate for a person who is X years old. Think about how we would modify this equation. If we want to represent 75% of the maximum heart rate, we can write the equation this way. Y equals 0.75 represents 75%, and then 200 minus X. For quick practice, let's evaluate this equation for someone who is 25 years old and someone who is 55 years old. So for someone who is 25 years old, it would look something like this. Y equals 0.75 times 200 minus 25, which equals 0.75 times 175, which equals 131.25 beats per minute for a 25-year-old. Okay, now let's evaluate this for a 55-year-old. So we have Y equals 0.75 times 200 minus 55, which equals 145. So that is 108.75 beats per minute for a 55-year-old. Great warm up. Now let's start with today's focus. As we begin, let's remember that a system of linear equations is 2 or more linear equations with the same variables. In lesson 11, we inspected the equations and graphs to determine the systems if they had one solution, no solution, or infinite solutions. We're going to expand on that today. So let's look at 3 graphs. You can either sketch a picture or you can take a picture, anything that works best for you. Here is graph A. Okay, here is graph A. Let's get all of that on the screen. All right, there we go. What do you notice about this graph? These lines intersect at one point. And from lesson 11, we know that this means the system has one solution. So let's make ourselves a note. Now, let's look a little bit closer. Can we estimate the ordered pair of the location of the intersection? Yes, we can. This point looks like it is at the ordered pair -3, +3. So the solution to this system of linear equations, the ordered pair that makes both equations true, is -3, +3. You can sketch a sample of this system on your paper. Now let's look at graph B. Let's look at graph B. What do you notice about this graph? Right, these lines are parallel. They will never intersect. Recall also from lesson 11 that this means the system has no solutions. There is no point of intersection that makes both equations true. Don't forget to sketch a sample of this type of system. Finally, let's look at graph C. Let's look at graph C here. What do you notice here about this system? I hope you notice that there's only one line. In this scenario, the two equations in this system actually represent the same line. We learned from lesson 11 that that means there are infinite solutions to this system, meaning that every ordered pair that represents a point on that line makes both equations true. Make sure you graph it or sketch a sample of this system on your paper as well. Now, let's extend this with a couple practice problems, but we will be graphing the linear equations on the coordinate plane ourselves to help find our solutions. Let's think about this. What is the easiest form of an equation to graph from? That's right. Usually, if we transform the equation into slope-intercept form, it becomes fairly straightforward to graph. Let's start by graphing this system of linear equations on the same coordinate plane. To get started, draw a coordinate plane on your paper and write down this system. I actually printed this one off of Math Aids, so that is a resource for you down here if you need some graph paper, or you can sketch your own. So here is our system of linear equations. So for this first equation here, can you identify the y-intercept? That's it, 3. This means we can place a point on the coordinate plane at 0, 3. Can you graph that on your coordinate plane as I graph that on mine? Here is my y-intercept. Now, what is the slope of that line? Excellent, it's 2. Remember that the slope is also described as rise over run. The value 2 can be written as 2 over 1. And so we can do that. We can graph that on a line by moving up 2 from the y-intercept and to the right 1. Graph the next point on your graph as I work on mine. So I'm going to go up 2 over 1. Now, using the straight edge, if you have one, draw a line through these 2 points to the edge and extend it beyond these 2 points to complete the graphic model of the linear equation. So how you can do that is you can just continue to rise 2 and run 1 until you go off of the graph paper. As you can see, there's going to be quite a few points here. I always try to go ahead and plot the points instead of just estimating by drawing. Now, if I want to draw my line in the opposite direction, instead of going up 2 to the right 1, I'm going to go in the opposite direction. So I'm going to go down 2 to the left 1. And then if you want, you can connect these points with a straight edge. I don't actually have a straight edge with me. So anytime that I'm in that situation, I just use the edge of a piece of paper. And I line it up to where it's touching all of my points. And there we go. All right. So here is our first line, y equals 2x plus 3. I'll highlight it to show that we have graphed that line. Now let's look at the second equation here. What is the y-intercept? That's it, -1. So let's plot the point 0, -1 on the graph. What's the slope of this second line? You got it. The slope is 2/3 for this second line. So the next point is going to be 2 units up and 3 units to the right of my y-intercept. So let's graph our next point. So I'm going to rise 2 and run 3. Now, using a straight edge, if you have one, or you can use the edge of a piece of paper like I did, draw a line through these 2 points to the edge and extend beyond these 2 points to complete the graphic model of the linear equation. If you want to make sure that your work is accurate, which you do, just continue to work going how the slope tells you to. So we're rising 2, running 3, rising 2, running 3. And if you notice, I see that if I continue to go in this direction, there's no way that these 2 lines are going to intersect. However, as I go this direction, it looks like they're going to intersect. So I'm going to, instead of going up 2 over 3 to the right, I'm going to go down 2, left 3. And you see right here, they intersect. So I'm going to draw my line here. All right. Great work. This is a complete graph of the system of equations. Now, as you can see, the 2 lines intersect. Here's my system. And so I know that this means there is one solution. And that solution is going to be the point where these 2 intersect, which is at -3, -3. So the solution to this system of equations, there's one solution, and that solution is -3, -3. Okay, let's look at another system to practice more graphing. So here's our system, and here's our graph. Okay, here we go. Go ahead and write these down. And let's start by graphing our first equation. Now, as you see, our first equation is a little different. This equation has a y-intercept of 3, but it doesn't have a slope. What does that mean? Do you remember? That's it. The slope is 0. This means that this equation represents what type of line? Did you say a horizontal line? You are correct. First, we're going to plot the y-intercept at 0, 3. Then, because it's a horizontal line with a 0 slope, we can simply put a second point to the right of the y-intercept. You make sure you draw along with me. So no matter what, doesn't matter if my x value is 1, my y value is 3, because the equation is y equals 3. If my x value is 2, my y value is 3. If my x value is 3, my y value is 3. No matter what, my y value is going to be 3. So now what we can do is we can draw a line representing y equals 3. All right, so here is our line, y equals 3. Okay, let's graph the second equation. What is the y-intercept of this second equation? You got it. The y-intercept is 2. So we're going to plot a point at 0, 2. What is the slope? Yes, the slope is -1/2. Let's plot the y-intercept, which we did, and now let's think about the slope of negative 1/2. Since the slope is negative, we can start at the y-intercept and move down 1 on the rise, since it's negative, and then to the right 2. If the points are plotted correctly, a line with a negative slope should slant down as you look from the graph from left to right. And what I always do is I do the name test. So when we write our name on this line that we're about to graph, if it's going downward, then that means that our slope is negative, which is what we want here. Okay, so we are going to go down 1 and to the right 2. And we're going to continue to move that way. Down 1, right 2. Now, if I continue to go this direction, I'm not getting anywhere close to this line. So I'm going to go back up, and I'm going to go up 1, but to the left 2. 1 and to the left 2. And now I'm going to connect the points with my line. So as you can see, the solution to this system of equations, since they intersect, we know that there is one solution, and that solution is going to be where the 2 points intersect, which is going to be at this point here, which is at -2, +3. So let's look at both the systems that we just graphed. So here are both of the systems that we just graphed. Here's the first one, and here is the second one. So we can see that in both of these graphs, the lines intersect at one point, just like we graphed together. This tells us that each system, of course, has one solution, and the solution is the ordered pair of the point of intersection. In the first system, the point of intersection was -3, +3, and that means that the solution to this system of equations is, it was -3, -3. So what that means is that the solution to this system of equations is -3, -3. In the second system, we figured out the point of intersection was at -2, +3. So that means the solution is -2, +3. Now that we've practiced graphing linear equations, let's look at some additional systems and look for solutions to the system. Draw another coordinate plane, or you can print one off like I have, and we will get ready to go. Okay, here is our next system. As we look at this system, we notice that the first equation is in slope-intercept form, but the second equation is not. Before we graph this system, what should we do? That's it. Let's transform this second equation. Follow along with me, but I think you remember how to do this. So we have 2x minus 2y equals -2. I'm going to move 2x over. Since it's positive, I'm going to subtract. And I have -2y equals -2x minus 2. Excuse me, that should be a y right here. And then I'm going to divide by my coefficient -2. Divide each term. And so I have y equals x plus 1. So here are my two equations. Now we're ready to graph the system. Let's start with this first equation here. Can you identify the y-intercept? You got it. The y-intercept is -4. So we will plot a point at 0, -4. The slope of the line is one in which we can express as a fraction 1/1. This means that our rise over run is up 1 from the y-intercept and to the right 1. Let's plot the next point and then connect the points with a line. So we rise 1 and we run 1. And I'm going to continue to do so both directions so I can extend my line. And we will use a straight edge or an edge of the paper to connect those 2 points, or to connect all of these points on the line. Now let's graph the second equation on the same coordinate plane using this transformed equation. The y-intercept is 1, so we will plot a point at 0, 1. The slope of the line is one which is the same as the first equation. So we can plot the next point that is 1 unit up and 1 unit to the right of the y-intercept and connect the points with the line. 1/1, up 1/1, and then we'll go down 1/1 so we can extend our line. Okay, and we will connect those points on the line. What do you notice about these lines? Did you see that the equations had the same slope but different y-intercepts? In lesson 11, we said that a system like this would have no solutions because the lines were parallel. Therefore, the lines would never intersect. This is a graphical model of a system of linear equations that has no solutions. I want you to remember these key points. You can write these down to help you remember later. So here's some key points I would like you to remember. If the equations in a system of linear equations have different slopes, they will have one solution. The solution is the ordered pair of the point of intersection in the graph. If the equations of the system of linear equations have the same slope but different y-intercepts, they will have no solutions, and the lines do not intersect on the graph. If the equation in a system of linear equations are the same line, they will have infinite solutions, and the equations are the same exact line. Let's look at a few more. You work along with me. I'll work through one of these for you, this time in context. Lynn is choosing a new music subscription plan. Company A offers a plan with no monthly fee, but does charge 20 cents a song for downloads. Company B offers a $1 monthly fee, but only 10 cents per download. If we let X be the number of downloads and Y be the total monthly cost of the plan, then the equations of this system of linear equations would look like this. Let's graph this system of equations and see if we can determine when the subscription plans would cost the same per month. You draw a coordinate plane on your paper and follow along with me. Let's start with Company A. The y-intercept is 0 and the slope is 0.20. How could we represent this as a fraction or rise over run? Did you remember that 2/10 is the same as 20 over 100 or 1/5? Great. Now we can use the fraction 1/5 for our slope on the graph. So let's plot the y-intercept and use the slope of the line to get our second point on the graph. So we're going to start at 0. And we're going to rise 1 and run 5. And we're going to do that one more time to extend our line. And then we will do it in the other direction. 1, 2, 3. Okay, and we will connect our points. Now, in the second equation for company B, how could we represent the fraction, or excuse me, in company B, we know that the y-intercept is 1. How could we represent the slope 1/10 as a fraction for rise over run? Yes, 1/10 is the same as 10 over 100 or 1 over 10. So let's plot the second line on the coordinate plane. We're going to start by plotting our y-intercept, and then we are going to rise 1, and we are going to run 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we will connect those 2 points. If you carefully draw the lines, you should see they intersect at 1 point. So we would say that this system has one solution. Look carefully at the graph. Where is that point of intersection? This is where the lines intersect. The coordinate pair that represents where they intersect is 10, 2. Now, what does that mean in context? If you said that it would take 10 song downloads for the subscription services to cost the same, then you are right. If you downloaded 10 songs in a month, you would be charged $2 for the month in either plan. All right, guys, that was a lot today. I'm very, very proud of you. You did some great work. So today we explored solving systems of linear equations by graphing. After this lesson, you'll have a few problems to practice on your own in the link that I showed you at the beginning of this lesson. Good luck and do your very best. I enjoyed graphing systems of linear equations with you today. Thank you so much for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.